1608 was a happening year. In that year, the Italian scientist Galileo became one of the first humans to view celestial objects with the newly invented telescope. Galileo improved on the design to see objects 10 times more clearly than ever before possible. With his primitive telescope, Galileo saw many thousands of previously invisible stars that make up part of our galaxy. The ancient Greeks named our galaxy the Milky Way because most of its visible stars appear overhead on a clear, dark night as a milky band of light extending across the sky. How many galaxies do you think are in the universe?
Maybe a couple trillion?
Well, I know there's at least one.
340 billion.
Those are all good guesses.
During the centuries following Galileo's discoveries, scientists created telescopes of increasing size and complexity. For more information on telescopes and something called optics, let's visit Marshall Space Flight Center in Huntsville, Alabama.
Optics is a study of light, what it is, how it moves through space, and how it interacts with objects. Light can be controlled with lenses and mirrors, and these elements can be combined into optical instruments like telescopes, lasers, and cameras, just like the one being used to take this picture now. There are two types of telescopes. This is a refractor telescope that has a lens in the front. This is a reflector telescope that has no lens, but a mirror in the bottom of it. The light from the object goes through the tube, is concentrated by the mirror to form an image which I see with my eye. Reflector telescopes are better for looking at faint objects like distant stars, and are therefore better for astronomy. I've taken this mirror out of the telescope to show you how the light is focused down to a spot at the focal point. This distance from the spot to the mirror is called the focal length, and there's an algebraic expression that relates the distance of the focal length, the distance u to an object, and the distance v to the image formed by the mirror. That expression is 1 over f is equal to 1 over v plus 1 over u. We use this equation to test telescopes here at the X-ray calibration facility. We want to have the object source as far away from the telescope as possible, so we put it at the end of this tunnel, which is 1/3 of a mile or 500 meters away. Then, with the telescope at the other end, we measure the image formed by the mirror very precisely to make sure that the telescope is built properly and will focus the stars correctly. And that's how we use algebra in optics.
Ground-based telescopes have revealed much over their nearly 400-year history, but they're really limited in what they can show us. Things like light pollution, cloud cover, and the Earth's turbulent atmosphere interfere with ground-based telescope observations.
So in 1990, NASA launched the Hubble Space Telescope, an automated reflecting telescope which orbits the Earth every 97 minutes. The Hubble telescope was named after Edwin Hubble, who discovered that the universe is expanding, and the more distant a galaxy, the faster it appears to move away.
Hubble's graph shows a linear relationship between distance and velocity. Remember the linear equation we used for the pizza graph? N times 2 equals P? Well, the linear equation for Hubble's graph is H times D equals V. H is the Hubble constant. It is similar to the number 2 in our previous equation. Remember there were 2 servings in one pizza? Anyway, D is the distance of the object, and V is the velocity or speed of the object.